Lesson 31 is called Systems of Equations, whereas the goal for here is to look at some graphs and then to solve corresponding graphs with algebraic methods. So in our first piece, it tells to sketch the lines of x plus y equals 6 and negative 3x plus y equals 2. So to do that, we need to have a grid. Your textbook does not have a grid. So I would either A, recommend you use graph paper, or B, just draw a nice X and Y axis somewhere on your paper and put a little grid, some little tick marks to represent your grid. So what we're going to do is we're going to focus on graphing these. When we want to graph these are currently written in standard form. Now, in standard form, we can change forms to y equals mx plus b, slope-intercept form if we want, or we can leave it alone. For this first one, I'm just going to leave it alone. So what I'm going to do is I'm going to create a little box. And I'm going to color that box in. I'm going to show you what I'm going to do with that box in a minute. We're going to fill it in. Let's see. Right there. I'm going to make that solid. And we're just going to make that a dark color. So, so if I'm doing this, if I want to solve this using standard form way, I can cover this y value up. And essentially what I create is a one-step equation where it says x equals 6. So that instantly tells me my x-intercept. So 1, 2, 3, 4, 5, 6 right there. And if I cover up the x now and I read it, I get y equals 6. So my y-intercept is also 1, 2, 3, 4, 5, and then 6. So that means I can draw a line that goes through those two dots as such. You want to make sure you're not just connecting the dots, but you are going through the dots, because we're going to be looking to see where these two lines intersect. Now, I could do the same thing with this one right here. I can cover these up, and I can solve a one-step equation, and so forth. But to just be able to show the other version, if I did not like this, so we showed standard form already. And the other option would be to do this version, which means solve for y. So that means I would take this version, the current negative 3x plus y equals 2, and I would move this to the other side, and I would get y equals positive 3x plus 2. So when I do this, this is y-intercept right here and my slope. So my y-intercept is positive 2. And then my slope is up 3, right 1. So 1, 2, 3 over 1. And then I can graph this line. And I can see that where the line's going to cross already, where they're going to intersect. It's going to be right through there. But again, your proper graph really should be extended to cover more of the graph, so we extend that out, and then we can see our solution, our proposed solution intersects right here at this location. If I wanted to show that algebraically, right now these two equations are written in standard form, so I can either swap the forms, or like I said, I could solve it in standard form. So I want to be able to get one of these equations to, one of these variables to go to 0. I see right here I have a match. So if I was to subtract my two equations, I would be able to eliminate the y variable. So 1x minus negative 3x would give me 4x. Y minus y would go to 0, so that goes away. Hence it is eliminated. And 6 minus 2 is 4. So now we have a one-step equation where we solve for x, and x is equal to 1. which would make sense. This point is at 1 comma 1, 2, 3, 4, 5. So now to solve for the y, I take my 1, which I now know, I plug it into one of these equations. The first one looks easier, so I'll put 1 plus y equals 6. Subtract 1 and find out that y equals 5. So that confirms my solution algebraically as 1 comma 5. So in our next problem, they're going to tell us, what if we take the second line and replace it with x plus y equals 2? And that means our first equation, x plus y equals 6, is going to stay. And we're going to take the second equation out and replace it with x plus y equals 2. Now again, this is a nice one. I'm going to borrow this. So we'll copy this. Let's see, copy, whoops, that did not copy. Copy, we're going to paste. So we're going to borrow this again. These two are very nicely solved using the method of standard form. So we're going to draw our x and our y axis. Make that line up better. Goes across there. So I cover up my y value. It reads x equals 6, right? We already know this. We're just re-emphasizing it. 1, 2, 3, 4, 5, 6. We cover up the x variable, and we read y equals 6. So 1, 2, 3, 4, 5, 6. And then we again add our line. That goes through here. We should extend our line in all directions. You should be using a ruler or some sort of straight edge to make your lines look nice and crisp. That would be an expectation. So now we come down here. We cover up the y variable. We find out that x is equal to 2, so we put a dot at 2. We cover up the x. It reads y equals 2. This technique again only works for standard form. And so then we draw our line that goes through these points. And what you're going to find out is you ended up with parallel lines. So let's move that out the way. So we ended up with parallel lines. Parallel lines is going to mean that we're going to have no solution. They don't intersect anywhere at all. And you can see that in our equation, that if I attempted to solve this, and let's say I want to get rid of either the x or the y, it doesn't matter, we would subtract here. And so x minus x would be 0x, and y minus y would be 0y, and that would equal 4. And so that doesn't work. That ends up being a no solution in our design. Let's see. To save us a little bit of writing, we're going to copy this. No, I guess that's not going to work. There we go. Click edit, copy. We'll take this one off and put this one here. And we'll get rid of this one. So they're saying this time, suppose the second line, right? So we're keeping the x plus y equals 6. And what if we changed it to 2x equals 12 minus 2y for the second equation? They want us to plot this one and see what's going to happen. So in this case, right, I might take this negative 2y and move it to the other side. So now I end up with 2x plus 2y equals 12. And so again, this becomes a good candidate for my my cover-up method here. So we'll copy this. We'll put it here. And since I chose to write in a different ink color, we'll switch these to blue, since that's what I'm going to be covering up. And so now if I cover up this part of the equation, it reads 2x equals 12. So that means if I divide by 2, I get x equals 6. So I end up with a dot here. And if I cover up my 2x, I again read 2y equals 12. So I divide, and I get y equals 6. So that's my y-intercept. And what ends up happening is my line ends up directly on top of the red line. So this is called infinite solutions. Infinite solutions. In other words, our two equations are exactly the same. And so since the equations are exactly the same, they're just multiples of each other, they end up creating the exact same line in that perspective. When we look at the next example in D, it says, we have seen that a pair of lines can intersect either 1, 0, or infinite number of points. Remember, this would be a solution, no solution, or infinite solutions. Are there any other possibilities with lines? The answer would be no. For a pair of lines, that is the only options that I have. So with that being said, we're going to go to exploratory challenge number 2. And it says, suppose that we have, instead of equations for a pair of lines, you were given an equation for a circle and an equation for a line. What are the possibilities for their two figures to intersect? So so the basic equation of a circle is x squared plus y squared equals r squared. Now, we can get fancier than that, but that's the very basic equation of a circle. So what they're asking us, if I have a circle, so we'll draw one. Let's say I put a circle right here. And then I had a line. What could possibly happen? Well, one thing that could happen is I could take that line and it could go right through that circle. And if it goes right through that circle, I'm going to have two intersection points. One here and one here. Now, it's possible, entirely possible. Let's see if we can get this to work. I'm going to duplicate that. It's entirely possible I have another circle. And what else could happen, right? I could have a line that's going to go through and just barely graze the edge. And if it barely grazes the edge, that means it interacts with that circle at only one point. Right? So there's also another possibility. Can you think of that possibility? That I have a circle, and it's quite possible that that blue line will completely miss that circle. And so in this case, right, we classify this as we could have two solutions. We could have one solution, or we could have no solution. So those are the possibilities. Now it says in part B, graph the equation of a parabola, right? So I don't know that we need the grid for this one in this case, so I'm going to take that off. And so they want us to graph x squared. So x squared, well, I guess we can leave the grid just for niceness sakes. if we have this possibility, right, so we draw a x-axis and a y-axis. So here's my x-axis. We'll clean that up in a minute. And then we have our y-axis like such. And so remember, if we're doing x squared, I like it to look nicer than that. Never hurts to have a little table. So we could pick some x values. Maybe -2, -1, 0, 1, and 2. And we figure out what each one is squared is. So that would be 4, 1, 0, 1, 4. So that would give us the graph of -2, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1. Right here. If we did another one, if we did -3, that would be 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right there. And then same thing on this side. So this would be our quadratic, or a parabola is the fancy word for that. They want to know, what are the possibilities for a line, like the circle drill that we just did? What are the possibilities of a line? Well, one obvious possible thing is the line could come through here and never touch it. So if it never touches it, we would call that no solution. There's also the possibility that I could have a line that just barely touches the edge of my parabola, meaning it would touch it approximately right there. We would call that one solution. There's also the possibility that I could draw a line and it could intersect that parabola in two locations. And so if we did that, it would intersect here, or it would intersect here. And then again, that we would call that a two-solution possibility. So now let's take a look at this. They say, sketch the circle given x squared plus y squared equals 1. So we're going to talk about what that looks like, how you can sketch that. So our circle, they tell us, is x squared plus y squared equals 1 squared equals 1. Remember, our equation circle is x squared plus y squared equals r squared. So that means if I was to take the square root of this number, it would still be a 1. So I know that my radius is going to be a 1. So I'm going to put a line, a dot here. And you know what I'm going to do? To be honest with you, well, no, let's just leave it as is. So here's my circle. I have a radius of 1. My center for now is going to be at 0, 0. When we get to a circle where the center is not at 0, 0, I will show you how to address that. So we're going to put a little circle on here. Right? I need to recenter my circle a little bit. So I have a circle with a radius of 1 from the center. They want me to then graph the equation y equals 2x plus 2. So they give it to the end, y equals mx plus b. So that means my y-intercept is at 2, which is right here. My slope is up 2 and over 1. So we're going to draw a line that goes through those 2 points. And what you're going to see is you're going to see this one is going to just barely graze the circle. I'm going to clean it up a little bit, like that. Though I think my line might be a little bit off. Let's see. Down to here, and then down to there. There we go. So that's a little bit better. My graph keeps on shifting. There we go. I should probably freeze that graph in the future. And so what we see is that this line intersects here and here. So this would have 2 solutions. We would anticipate this to have 2 solutions. So what we're going to do is we're going to find those solutions. That's going to be in part D. So we don't actually need this grid, but just for visuals, I will copy this grid here so we can continue to see it to here. And what they want to do, they want us to substitute y equals 2x plus 2 into this equation and solve for x. So to do that, right, we now know what y equals, so we're going to write x squared plus, and where there's y, we're going to write 2x plus 2 squared and set it equal to 1. And they want us to solve. So what we have to do is we have to write this part down twice, because I have to multiply it out as such. And so we have x squared, and then 2x times 2x is 4x squared. 2x times 2 is 4x, and 2 times 2x is another 4x, and 2 times 2 is 4, and we set that equal to 1. So we'll simplify. 1x plus 4x squared is 5x squared. 4x plus 4x is plus 8x. And we have a plus 4 equals a 1. We're going to subtract 1 to the other side. So now we get 5x squared plus 8x and then plus 3. That's now equal to 0. And what we're going to attempt to do is factor. If factoring doesn't work, we'll lean on the quadratic formula. So we'll put 5x and x. We're going to put a 3 and a 1. How do I know that this works out? Because this is 3x and this is 5x, and it adds up to equal 8x. So now that I have that, I set each one equal to 0. And so that means x is going to equal negative 3/5, and x is going to equal negative 1. Right? So that's my 2 pieces that I get for letter D. They want to know, if I want to know more specifically where they are, well, I can take each of these x values and I can plug them back in, and I'm going to get a result. So that's what we're going to do in part E. Use what we did in part D to find the intersections of the circle. So remember what we just did. We found out that x was equal to negative 3/5, and x was equal to negative 1. I'm going to take my equations. The easier equation would be the y equals 2x plus 2, and I'm going to plug each of these in there. So 2 times negative 3/5, and then we're going to add 2. And so after you solve that one, right, I'm not going to show all the work for that, but once you plug that in, you're going to get 4/5. When I do the equation again, and I plug in the negative 1, y equals 2 times negative 1 plus 2, you're going to get y equals 0. So what do I know, or what have I learned? That my intersection points are at negative 3/5, comma 4/5, and negative 1, comma 0. That is where my circle intersected both here. You can see this is there and then we got one over there. Now, of course, the algebra is very important because you wouldn't have guessed negative 3/5 and then 4/5 and then negative 1 and then 0. So what we have left here is a series of exercises that is going to ask us to graph some of these. So we'll look at some. I don't know if we'll do all or not because there's quite a good bit of them. But if we start by drawing a y-axis and an x-axis, they want us to graph x squared plus y squared equals 9. So far what we know about that is the center is going to be at 0, 0. Anytime you have just x squared plus y squared, your center is always at the origin. And since it equals 9, and that's r squared, we know that our radius is going to be the square root of 9, and so our radius is going to be 3. So that means when I graph this, I'm going to go 1, 2, 3 in this direction, 1, 2, 3 in this direction, 1, 2, 3, and then 1, 2, and then 3. So then we're going to draw our circle. So it's approximately 3 in every direction, right? I'm going to recenter this. It needs to go a little bit larger. There we go. That would be our circle with a radius of 3. And the line y equals 2. So the line y equals 2 is actually a horizontal line at y equals 2 right here. 1, 2, and that goes across right there. And so by doing that, we can see that the intersection points are here, approximately, and here. Right, and so that those would be our given solutions. What happens when y is equal to 3, right? So for the graph, what happens when y is equal to 3? Well, if we move it to 3, right, it comes up to the top right here, and we have one solution. And if we go up to 4, we have no solution, right? 2 solutions, 1 solution, no solution. So that would be the goal behind that one. I'm going to leave it at that. That leaves you with the remainder of the exercises to practice. If you decide that you need to ask anything from exercises 1, 2 through 6, you can let me know, and I can obviously model that live if you need to. Other than that, that would end the video for this particular lesson.